Hey everyone, let's finally talk about fracturing or breaking stuff. So far we've only worked with pieces that were already separated, but we didn't actually break them ourselves. And before we actually look into all the details about fracturing, let's start with some general overview to not get lost. So first of all, something you have to understand is that we do not actually break things the moment they hit something. So we're not doing simulations on a level of actually simulating how an object would break if it would hit another object or something like that. We are not working with physics on that level. We are basically entertainers. So the systems we're using in Houdini are kind of based on physics, but we don't go as far as actually analyzing the structure of an object to get realistic breaks. It's all about looking realistic enough and being fast enough to work with it. So what we're doing is we take an object like this statue here and then we break it apart into pieces. And then we can glue it together if we want, but in the beginning we will not even do that. We just let it fall down and then the object will break exactly into the pieces we pre-fractured it into. Now why would we do this? There are two reasons for this. First, speed, and second, control. So control means we just want to be able to control exactly how it looks like, because if we're not happy with the result, then we can change it at any point. So for example, I could decide I want to break the arm here as well, or maybe the head as well, stuff like that. I want to be able to control exactly how our pieces fall apart. And then you can imagine if I don't have to let the computer calculate how the pieces will end up after such an impact, it will be much faster to simulate that. So instead of maybe a couple of hours, it takes only a couple of seconds to simulate this kind of stuff. So this is why we work with pre-fracturing instead of an actual breaking up during the simulation. By the way, this is actually possible in Houdini. So if that interests you, you can always do some research on that. But in practical terms, in the industry, nobody does that because of the limitations we just talked about. Now, when it comes to fracturing, there are basically three main techniques that are used. The first one is a so-called Voronoi fracturing. And of course, we will talk about all those techniques in way more detail in the coming videos. But first, I want you to have an overview of the main three. And the Voronoi fracturing is basically the oldest and simplest way of doing it. It basically just fractures an object automatically into pieces based on a point cloud. We will talk more about this. Basically, the main advantage of this is it is the fastest approach, but also the one that by default, if you don't change anything about it, looks the most boring. Because what you get is those very evenly sized pieces and you don't have much variation or detail. Of course, you can add all those things to a Voronoi system, but by default, it's not there. This is why side effects implemented at some point the so-called RBD material fracture, which is basically a Voronoi internally, but it results in more interesting shapes and more variation in the scale, which when you simulate that, as you can see here, creates much more interesting shapes. The problem with an RBD material fracture is it takes much longer to do the actual fracturing. I have prepared this here, but this, depending on your geometry, it can take a long time to actually break this up, whereas the Voronoi is much faster. And then there's a third technique which is used for the kind of hero destruction settings and is used by most senior effects artists, and that is a simple Boolean fracture. So instead of letting a system automatically fracture our objects, we give it some cutting geometry that would look like this, for example, and we create them ourselves. And we can really fully control where the fracturing is supposed to happen. It's easiest to understand if I quickly show this just with a single grid. So I take my geometry here and I position the cutting area by hand exactly the way I want it. Let's say something like that. Then I can put a mountain on top. And then the fractured version looks like this. So I have really full control over how my geometry is cutted apart. And this, of course, gives me the most control. Disadvantage of this, of course, is it's the most work because you basically have to generate all the cutting pieces yourself, and this is how this can look like in the end. Takes a long time, but of course gives you the most control. And the results are usually pretty good, so this is why this is something a lot of senior artists rely on. So those are the main three techniques, and as a rough overview here you can see the three results. The first one, the pure Voronoi fracturing, is by default very even and kind of boring, but very fast. The second one is the RBD material fracture, a half-automatic system built by Side Effects, which is based on a Voronoi system, but adds a lot more detail to it. And then the one with the most control is the Boolean fracture, where we basically just cut a geometry in pieces exactly the way we want by providing the cutting surfaces. So those are the 3 techniques we will look at, and each of them have advantages and disadvantages. For example, you don't want to have background geometry cut it manually with a Boolean fracture that would simply take too much time. That only really makes sense for the hero assets. But also similarly, you don't want to have the hero asset automatically generated with a Voronoi, which can be really boring. By the way, the Voronoi is also a very cool technique for modeling as well, and we will start with that for that reason. It's very helpful to understand how Voronoi behaves, so that we can actually use it for other stuff than just RBD destruction. So yeah, I hope this is helpful as an overview, and in the next couple of videos we'll go much deeper into each of the techniques. Just for now, so that you have an understanding what we're doing here, this is an overview. I hope this is helpful. Thanks very much and see you later. Cheers.